In 2024, the Amazon's main rivers hit their lowest water levels in over 120 years of recorded history. Boats sat stranded on cracked riverbeds. Dead fish rotted in pools of contaminated water. Villages that had relied on the river for centuries were suddenly cut off from the world. No food deliveries, no medicine, no way out. This wasn't a drought in some peripheral tributary. This was the main artery of the largest rainforest on Earth. The river that carries one-fifth of all the fresh water on the planet, running dry. And here's what makes this so alarming. The Amazon doesn't just belong to South America. Its trees regulate rainfall patterns thousands of kilometers away. Its forests absorb carbon that would otherwise accelerate warming for every country on Earth. Scientists have identified a tipping point, a threshold beyond which the Amazon stops sustaining itself and begins to collapse. And according to the latest data, we are already dangerously close. To understand why the Amazon's disappearance threatens the entire planet, you first have to understand what it actually does. The Amazon rainforest covers 5.5 million square kilometers across 9 countries. It is home to 10% of all known species on Earth and 30 million people, many of whom depend on the river directly for food, water, and transportation. The Amazon River itself discharges more fresh water into the ocean than the next 7 largest rivers on Earth combined. One-fifth of all the fresh water that flows into the world's oceans comes from here. But the Amazon's most important function isn't the river you can see. It's the one you can't. Every day, the Amazon's 390 billion trees pull water from the soil through their roots and release it into the atmosphere through their leaves. This process, called transpiration, pumps around 20 trillion liters of water vapor into the sky every single day. That vapor doesn't just disappear, it forms clouds. Those clouds move, and when they release their water as rain, they feed rivers, crops, and ecosystems thousands of kilometers away from the forest itself. Scientists call these streams of atmospheric moisture flying rivers. And they are, in every meaningful sense, exactly that. The Amazon's flying rivers carry an estimated 200,000 cubic meters of water vapor every second across the South American continent, delivering rainfall as far south as the Argentine agricultural heartland, over 3,000 kilometers away. This is the Amazon's hidden infrastructure, a continent-wide water recycling system built entirely out of trees. And it only works as long as the trees are standing. Remove enough of them, and the flying rivers weaken. The rainfall they deliver drops. The farms and ecosystems that depend on that rainfall begin to dry out, and the forest itself, which needs that recycled moisture to survive, starts to lose the one thing it cannot live without. For decades, the Amazon has been cleared at a pace that is difficult to fully comprehend. Between 2001 and 2020, the Amazon lost approximately 9% of its total forest cover. The primary driver was livestock farming. Ranchers pushing further into the forest, clearing land for cattle pasture, yet repeating the same pattern that began back in the 1970s when Brazil's government first opened the rainforest to settlement. Soy farming compounded it. Roads followed. And with every hectare cleared, the water machine described in the last section lost another working part. Here is the mechanics of how deforestation breaks the water cycle. When a living tree is removed, the water that it would have pulled from the soil and released into the atmosphere simply doesn't get released. It runs off instead. Studies show that in deforested areas, more than 50% of rainfall becomes surface runoff, rather than being recycled back into the atmosphere. That means less moisture feeding the flying rivers. Less moisture means fewer clouds. Fewer clouds means less rain, not just over the cleared land, but over the forest downwind of it. And that's where the cycle turns vicious. As rainfall drops, the surrounding forest becomes drier and more stressed. Stressed trees are more vulnerable to fire. Fires kill more trees, and every tree that burns is one less pump in the system, accelerating the very drought that caused the fire in the first place. Deforestation and drought don't just coexist, they feed each other. The political dimension made this worse. Rollbacks of environmental protections, weakened enforcement agencies, and legislation that made it easier to claim illegally cleared land, all sent a clear signal to ranchers and landowners. The forest was open again, and they responded accordingly. The result was a landscape increasingly unable to sustain itself, stripped of the very trees that kept it alive. Deforestation alone would be devastating enough, but it isn't operating in isolation. While ranchers and farmers were clearing land from the ground up, a separate force was dismantling the Amazon's climate from above. Human-caused climate change has fundamentally altered the conditions under which the Amazon exists, and the data makes this impossible to ignore. Over the past 40 years, the Amazon has warmed at an average rate of 0.27 degrees Celsius per decade. That might sound modest, but in the southeastern regions of the forest, the rate has been nearly double that, reaching 0.6 degrees per decade. For an ecosystem calibrated over millions of years to operate within a narrow climatic range, that kind of shift is enormous. The dry season tells the clearest story. In the southern Amazon, the dry season once lasted 3 to 4 months. Today it runs 4 to 5 weeks longer than it did 45 years ago, and it delivers 20% less rainfall than it used to. The forest gets less water for a longer period every single year. Research confirms that human-caused climate change is now the primary driver of drought in the Amazon, making extreme drought events up to 30 times more likely than they would be in a stable climate. This isn't a projection, it's a measurement of what has already happened, and scientists have identified a specific threshold that changes everything. If the dry season extends to 6 months, vast areas of the Amazon could cross an irreversible boundary, a point where the forest can no longer recover between dry seasons and begins converting into something else entirely. But here is what makes this so dangerous. Climate change and deforestation do not simply add their damage together. They multiply it. A forest already weakened by logging and burning has far less resilience against a longer, hotter dry season. And a longer, hotter dry season makes every fire more destructive and every cleared patch harder to recover. The two forces are accelerating each other, and the Amazon is caught in the middle. The data and the science had been warning about this for years. Then the droughts arrived and made it impossible to look away. 2023 and 2024 were the most extreme drought years ever recorded in the Amazon. Not by a small margin. By measures that broke every benchmark scientists had established over more than a century of record-keeping. In Brazil alone, the Amazon biome lost over 8 million acres of surface water in 2023. That is an area 25 times the size of Los Angeles, gone from the map in a single year. The Amazon's main rivers recorded their worst water level declines in over 120 years. Rivers that had sustained communities for generations shrank to a fraction of their normal volume, and in some places they stopped flowing altogether. In Peru, the numbers were even starker. Between August and October of 2024, river flow dropped by 82% compared to earlier that same year. Water levels fell approximately 11 meters. Flow speed was reduced by 64%. These are not gradual changes. These are collapses. For the 30 million people who live in the Amazon basin, this wasn't an abstraction. Villages were cut off as rivers dried up. Dead fish contaminated drinking water. Wildfires spread across drought-stricken land, collapsing air quality across entire regions. Even communities that had never needed outside help suddenly had no way to receive it. The fires compounded everything. Since the start of 2023, more than 11.8 million acres of Brazil's Amazon have been consumed by fire. An area twice the size of Maryland burned in under 2 years. The consequences reached the energy grid as well. Brazil's Belo Monte Dam, one of the largest hydropower plants in the world, with a capacity of over 11,000 megawatts, generated an average of just 145 megawatts per day during the peak of the 2024 dry season. Roughly 1% of its full capacity. The Amazon was not slowly declining, it was visibly breaking down. What the droughts of 2023 and 2024 revealed wasn't just a bad few years. They revealed how close the Amazon has come to a threshold that scientists have been tracking with growing alarm. The tipping point. The moment when the Amazon stops being a self-sustaining rainforest and begins an irreversible transition into something closer to a savanna. Not a metaphor. A documented ecological mechanism with a measurable trigger. Here is how it works. The Amazon generates a significant portion of its own rainfall through transpiration. The trees pull water from the soil and release it into the atmosphere, feeding the clouds that rain back down on the forest. The system is self-reinforcing, as long as enough trees are standing. But remove too many, and the forest can no longer produce the rainfall it needs to survive. It begins to dry out from the inside. Trees die. More moisture is lost, more trees die. The cycle runs in reverse and it accelerates. Think of it like removing bricks from a wall. Take a few and the structure holds. Take too many and the whole thing comes down at once. Estimates of total Amazon forest loss vary depending on methodology, but multiple scientific assessments place the figure somewhere between 13% and 20% when degraded areas are included. Scientists place the tipping point threshold at 20 to 25% total loss. Under current deforestation rates, some projections suggest that threshold could be reached within years, not decades. That is not a comfortable margin, and the consequences would extend far beyond the forest itself. Models estimate that losing 40% of the Amazon would reduce rainfall in Argentina's agricultural heartland over 3,000 kilometers away. Complete loss could melt 50% of the Sierra Nevada snowpack and cut rainfall by 20% across the Pacific Northwest of the United States. Globally, temperatures could rise an additional 0.25 degrees Celsius above current projections, a small number that translates into cascading disruptions across every continent. The most sobering part is this: we will probably not know we have crossed the tipping point until it is already behind us. The picture painted by the science is severe, but severe is not the same as inevitable, because alongside every data point showing the Amazon in decline, there is evidence, documented and measurable, that the right interventions actually work. The question is whether they will be applied at the scale and speed the situation demands. The most powerful proof comes from the people who have lived in the Amazon the longest. There are over 1.5 million indigenous people living in the rainforest, and the data on what happens to the forest under their stewardship is unambiguous. Between 2001 and 2021, portions of the Amazon not managed by indigenous communities emitted 270 million metric tons of carbon into the atmosphere through deforestation and burning. During that exact same period, portions managed by indigenous people removed more than 300 million metric tons. Same forest, same decades, opposite outcomes. Protecting indigenous land rights is not a cultural gesture, it is one of the most effective climate interventions on the planet. Forest restoration also matters. Planting new trees helps rebuild the water cycle and restore transpiration in degraded areas. It takes generations for a replanted forest to match the carbon storage of old-growth trees, but the rainfall benefits begin returning much sooner. Consumer pressure has a proven track record as well. The soy moratorium of 2006 demonstrated that sustained pressure on major food companies can change the behavior of an entire industry. Corporate supply chains can be redirected. They have been before. And the economic argument for protection is stronger than it might appear. Researchers estimate that sustainable land management and fire prevention could generate more long-term wealth than the current extraction economy, which already produces the equivalent of $98 billion annually. The tools exist, the science exists, the precedent exists. Brazil demonstrated in the 2000s that deforestation could be cut by 70% without collapsing the agricultural economy. What made it work then was political will. That remains the central variable now. Come back to where we started. Find a river running dry. Boats grounded on cracked mud. Villages cut off from the world. Fish rotting in what used to be water. This is not a preview of what might happen. This is what is already happening. To 30 million people right now, while the rest of the world debates timelines and thresholds. The Amazon was pulled back from the edge once before. In the 2000s, deforestation rates dropped by 70% through a combination of political will, international pressure, and economic creativity. The tools that saved it then still exist. The science that explains how to use them is clearer than ever. What the Amazon needs is not a miracle. It needs a decision. The world's largest river is disappearing. The tipping point is close. And the only thing standing between here and irreversible is whether enough people decide that this forest is worth more alive than gone. Thank you for watching. If you value stories like this and want to support more independent documentaries, consider subscribing to the channel. Continue the journey, watch the next film, and explore the story further.